Hi, and welcome to this first episode on the development of the Performer Eurorack sequencer, an open source, open hardware project that I started almost a year ago. The project is, I'm posting about it on Facebook on this Performer sequencer page. You can also find the source code for the firmware on GitHub. There's also a separate repository um, with the hardware design files. So, first up, sorry for the pretty poor audio quality. Um, I'm running a not optimal setup here for this first stream. I hope to improve on that in the future, but for now, this is kind of what I have to live with. So unfortunately, I will not be able to show the actual hardware today. So all the demos I will do is with the simulator, which I also use for the actual development most of the time because it's just more convenient. I don't really have an exact plan for this stream. The main goal for me is to kind of talk a bit in general about the project, the background, why I'm doing it, and then kind of go into the current state of the development, what's working, what's kind of planned, where I'm at. I hope this will give people a better understanding for kind of the functionality of this sequencer, and also give them a way to maybe give me some feedback on how they feel about certain features, if I'm overlooking some obvious things that are probably not important for me, but maybe super important for other people. So, oh yeah, one last thing, my internet connection here is not the most reliable, so if the stream should break up, I will just continue on my end and then upload an off-screen recording that I'm doing at the same time. So let's get started. Who am I? I'm Simon. I live in Switzerland. I'm 35 years old, and I've always been interested in making music and also been programming since a pretty early age. And I did know modular synthesizers for quite a long time, but I never really got into it because it just seemed like a huge investment and especially a never-ending investment. So whenever I could, I was playing modular systems from other people, from friends, but I never really uh, went into it myself. But that changed around 2 years ago when I was working on a hardware-only setup for uh, making live music, and then I decided to build a small Eurorack just for kind of effects. But yeah, obviously that got out of hand pretty quickly. But I decided quite early on that I wanted to do everything kind of DIY, because when I found out that there are so many projects, so many modules you can build, I thought, well, first I can probably save a bit of money. Also, it's harder to just go crazy because you don't just buy finished modules, but it's always kind of a time investment to build them. So I thought maybe that helps to not get out of hand that quickly. So yeah, 2 years later, I have a pretty large Eurorack system, all DIY. But I had the problem that I never really found a good sequencer, at least DIY sequencer. I've built a MIDI box sequencer before, which is a DIY project, but I found it not to be super suitable for driving a Eurorack system, at least not for what I wanted to do with it. So yeah, that's where I kind of had the idea of actually doing my own thing. So what is it? Basically, the idea was, build my own sequencer, and because I've used quite a few different ones over the years, I just had some ideas and some features that I had in mind that are probably just important for me, but I kind of wanted to have a sequencer that's my own, that's doing more or less exactly what I wanted to do. And then there's kind of a larger goal behind this project, because I always kind of had a dream of maybe at someday developing my own synths or modules, or kind of just in general devices for music making, and not just software but actually real hardware. So I thought this project was a good way to go through the process of designing the hardware and developing the software and kind of create this product. And really early on, I decided, I mean, for me, that's not really a question, but I wanted to make this open source from day one, more or less, because over the years, I've learned so much from different open source projects that it just makes sense to kind of do the same. Especially the mutable stuff, mutable instruments. That was a huge resource for me, because Oliver uses the STM32 processor line that I actually used before professionally. So seeing those chips in modules, it was just nice to see how he uses them, what he's doing with them, what they are capable of also. And so, I decided to start this project, and the first kind of goal was to make it open source and to make it in a way that people can actually DIY this thing. I don't plan to make kits or even sell PCBs. I think there are other people and other companies that are way better with these kinds of things. But I just provide the software and the hardware design. And then further down the road, if there's potential, if I see that people actually like what I'm doing and there's a use for this, then I would like to at some point start a Kickstarter campaign with the goal of actually manufacturing ready to buy Eurorack module. But I would say that's still like half a year or even further down the road, because I will first have to do a lot of kind of research on what's involved with manufacturing, kind of the pricing, also like how many do I have to sell to even make it feasible. And so that is just necessary to kind of start this campaign and have it in a way that actually makes sense. But I mean, if I would succeed with the Kickstarter, then that would be sort of the that would tell me that maybe I could continue with this and maybe do other projects and maybe at some point even start a company. But yeah, that's kind of dreams in the future. So let's talk a bit about the sequencer itself. So yeah, this is just a very rough overview of the features. So basically it's an 8-track sequencer, so you have 8 gate and CV outputs. Each track has up to 16 patterns or sequences, and each of those sequences is 64 steps long. In the current design, I'm using this kind of indexed voltage tables concept, which is also used by the ER 101 from orthogonal devices. So basically, that just means you enter numbers, and each number corresponds to a given voltage, and so you're really free in kind of what scales you want to use, or yeah, you can do all kinds of weird things that you cannot really easily do with sequencers that are just chromatic, like 12 semitones. The sequencer has a pretty flexible clock setup, so it can be a master clock. Obviously, it has clock inputs and outputs, reset inputs and outputs. It has MIDI and USB MIDI. And so, yeah, it can basically use all of these sources and destinations for clocking. Then there are multiple track modes, so not every track necessarily needs to be the same. There's the node sequencer, which is just kind of the standard mode. There's a curve sequencer, which is not really fleshed out right now, but it's basically meant to be used for modulations. And then there's currently a MIDI to CV mode, so the sequencer can act as a pretty sophisticated MIDI to CV converter. I will show some of that in the demo. Furthermore, it has this routing system, which basically allows you to use CV inputs and MIDI inputs to control certain parameters of the sequencer. So the idea here is, because it has this USB MIDI host port, it should be pretty easy to connect just a standard MIDI controller. And this just allows you to map certain parameters to quickly access them in a live performance. Then there's a snapshot system in my mind. I haven't really fleshed it out, and it's not implemented yet, but the idea there is it should be easy to sort of create stuff on the fly, and then either keep it or just remove it immediately. So this is both very useful when you create new sequences or do kind of a studio environment to do this kind of work, but also in a live situation, it's cool to have something that allows you to experiment with things and do crazy stuff, and then just go back if you find it's not going in the right direction. So that's sort of the idea here. And then this last point, algorithmic generators. I didn't find a better name, but the main idea there is, instead of just allowing sequences to be edited like one step at a time, I want explore different ways of generating sequence data in algorithmic ways, so you can pretty quickly create more complex stuff. But yeah, again, this is just on paper for now. I've done a bit of work on like super simple things like Euclidean rhythms, but yeah, I have some ideas that I want to try out, but there's just other stuff that I want to finish first. Then in terms of hardware, the current design uses this STM32F4 processor, which is running at 168 megahertz, so it's pretty beefy. It has 1 megabyte of flash for firmware and 192 kilobytes of RAM, which turns out to be a bit of a challenge. But the thing is, this is kind of the largest chip in terms of memory for the given package size, so I didn't want to use a large IC, so this is a 64 pin, and in that category it's kind of the most the best you can get. Then I'm using a 256 by 64 pixel OLED display. This is really nice because it allows me to show quite nice UI for the sequencer. Also, in contrast to other modules I've seen, the way it's implemented is actually refreshing at, I don't know, like 30 frames per second, redrawing everything, so it's really fluid and really nice to kind of visualize things. Then I have one encoder with the push button to navigate. There are 37 switches, and 32 of those have bicolor LEDs. There are 8 gate CV outputs. The CV outputs are using a I'm not sure, 14-bit or 16-bit DAC. 4 CV inputs, 12-bit resolution, and clock reset inputs and outputs. And then there's a MIDI in-out on, not on the DIN socket, but on the just standard mini jack that's used on a lot of devices today. So unfortunately there's not a standard, so there are different pinouts. And then there's USB MIDI, so you can hook up MIDI controllers through USB. And the last thing is an SD card slot, which allows you to save and load projects, do firmware updates, stuff like that. So this shows the early prototype that I did using a eval board, and then just stuff on protoboard. And so this allowed me to just have a proof of concept and work on the drivers, make sure that the hardware works. And when I actually didn't have a fully working sequencer, so at some point I just didn't want to invest more time in this prototype, but actually started with the first revision of the PCB, which was quite a painful process. Just takes a lot of time, but I got it done at some point. So this is the PCB and the front panel, and then this is what the unit looks like. Unfortunately, the front panels didn't get manufactured right, so it was my mistake, but it still works for prototypes. So there are a few issues on the hardware at the moment, so I had to do a few hacks on the PCB to make it work. They are all documented on the GitHub project. But I have basically solutions for all these problems, but it requires a bit of redesign that I haven't done yet, but I hope to soon find time to actually work on revision 2, which should then also be the one that people can actually use to build their own sequencer. So next, let's talk a bit about the software. So it's written in C++11. I'm using a few third-party libraries. I'm using FreeRTOS as the real-time operating system kernel. basically just for thread switching. Then libopencm3 is a library to talk to the STM peripherals. libusb host is a library to allow basically for me MIDI USB devices over the STM32 USB host functionality. SDB-printf is just for printf debugging or kind of printf string formatting, and FAT is obviously the file system. And then, one important thing is there is absolutely no dynamic memory in use in the sequencer, which is really important for embedded software. Because first of all, there is not a lot of memory, and then you don't want to run into problems where you have fragmentation and you cannot allocate memory, even though you have it available, but it's just fragmented all over the place, so you can't allocate the memory you need. So yeah, this makes certain things a bit more complicated, but it's important to get that right, to have stable software that actually runs for hours without a problem. And then the firmware currently runs on the hardware and also in a simulator, which I use for development. And there is even a version that works in a browser. So initially I had this idea of putting this version online so people can use it without actually having to build the sequencer, just to kind of check out the functionality. But it's not super convenient, so there's no release yet. Maybe I will do one in the future. And then let's quickly look at sort of the software architecture. So you have this sequencer application, which is using the operating system, FreeRTOS, and then there are these yellow blocks here, the device drivers that talk to the actual hardware. So there is analog digital conversion, digital analog conversion, like all the buttons and LEDs, some digital I/O, MIDI, USB, MIDI, the SD card with the file system support, the LCD obviously. So this is what runs on the hardware, and then for the simulator it actually runs the exact same firmware, but then everything around it is kind of rewritten. So all the device drivers kind of talk to the UI, or talk to, like, USB MIDI and MIDI talks to actual MIDI devices that you connect to your computer, so you can test all that stuff. And then in addition to that, there's a small synth and sampler engine. So in the simulator, that allows me to actually hear something if you create sequences. This is not part of the sequencer itself, it's really just part of the simulator. There are some differences in terms of the operating system, obviously. So one kind of huge difference between the actual hardware and the simulator is that the hardware runs on multiple threads, which have different priorities. So the engine thread, which is responsible for actually outputting the sequences, runs at the highest possible priority. So the timing is always like really accurate. And then everything else, like UI, stuff like that, is sort of lower priority, so it never interferes with the real-time characteristics of the sequencer itself. And this is not really the case in the simulator, so performance in the simulator is actually quite a bit worse. Also, like, timing accuracy is quite a bit worse. Because that's the main reason it runs in a single thread. which was a choice that I made because WebAssembly, the browser doesn't allow to run multiple threads. So yeah, just keep in mind that if you feel that like the sequences or the timing is jittery, it's not exact, it's not accurate, that's really just a simulator. It's not a problem on the real hardware. So yeah, then I think we will go into the demo. So let me start the thing up. So this is the simulator. So you can see you have the LCD as it would be on the real hardware. You have the encoder here, which I can use my scroll wheel to kind of simulate the encoder. You have all the buttons down here. And so one nice thing with the simulator, I think, at least for this demo, is you can actually see when I press a button and which button it is. These controls down here are feeding the CV inputs. So on the hardware I have 4 CV inputs, and so these just allow me to simulate the voltage -5 to +5 volt that are coming into the sequencer. So yeah, let's first talk a bit about this kind of block of buttons over here, which are sort of the global functions. So there's a shift button, which is used to, obviously access kind of additional functions. There's a page button, which allows you to switch through different pages in the sequencer. There's a left and right arrow, which can be used for navigation as well as for different things in the different pages. There's a snapshot button, which currently is not doing anything, and then there's a performer button, which is also not doing anything, but the idea there is there's a performer page that I will show you later, and the idea was to have this available on a button so you can quickly access some of those performance related features quickly. There's a play button, which starts and stops the sequencer, and there's a tempo button where you can adjust BPM. There's also, if you keep the tempo pressed, you can use the play button to enter tap tempo. And then there's another feature: if you use the left and right keys buttons, then you can notch the tempo. So that's a feature, for example, that's available in Ableton, which can be useful if you align if you want to align your tempo to some other track playing on another device, like on a turntable or something like that. Then there's pressing shift tempo. Actually, that should be page tempo, but yeah, for now it's shift tempo. And there's the clock setup page. So here you can set up the clock master slave or auto detection. You can set up the parts per quarter note on the analog clock inputs. So you can set up the division here. Also, if the input is actually a reset, the reset input is actually a reset or a start-stop signal. And then you have the same for the output clock. You can have a separate division. You can You can configure a pulse length. And finally, you have MIDI clock receive and MIDI clock send. I'm not sure if using MIDI clock over USB will be that helpful, because there's quite a bit of jitter and latency, even in standard MIDI, but it's even worse with USB MIDI. So I think for sending out MIDI clock, it's probably sort of okay, but for receiving MIDI clock over USB, it's probably not the best idea. So yeah, the first page right here is the project page. Some pretty boring stuff. You can add a name or set a name. Yeah, I just pressed cancel, so it didn't take changes. That's okay. Oh yeah, maybe one thing I forgot to mention are these F keys up here, those 5 keys. So they are aligned to the LCD, to the display. So on a lot of pages you have these kind of soft buttons. So what the button actually does is kind of written here on the display. So I think that's a neat way to yeah, you don't have to remember everything, but you can actually see it on the display what a given key does. Yeah, maybe let's also go over the rest of the buttons. There are 8 track keys, the top row, and then there are 16 step keys. So, but depending on in which mode, which page you are, obviously these have sometimes different functionality. But in general, the track keys select the track, so you can see that up here, T1, T2, 3, 4, whatever. P stands for the pattern, the current pattern. And then, yeah, step keys obviously are used to enter sequences, but also do a lot of other stuff. So yeah, back to the main page, you have also the BPM, which you can set here, or just by holding the tempo key, you can also adjust it globally, or yeah, from wherever you are. There's a swing. Right now it's a global swing. I will probably allow different tracks or even sequences to override this global setting. And then there's a sync measure, which yeah, will be relevant for things like changing patterns, muting, unmuting tracks. So you can always perform these actions immediately, or you can kind of sync them to this number of measures here. I will probably have to reiterate on that a bit, because right now this assumes a 4/4 rhythm, or yeah, division, and this might not be flexible enough. Also, yeah, one concept that I'm using in quite a few places is, if you scroll through the values here, it's jumping to kind of the most important ones. So here it's just powers of 2, but then if you hold shift, you can actually select every in-between value as well. So that's the project page. There's a concept that's available on quite a few pages, which is you can hold page and shift together, and this opens up this kind of context menu. I will also add icons here, so it stands out a bit more. Yeah, maybe looks a bit nicer. So what you can do here is basically initialize the project, so you can just reset it. You can load, save as, and for now also format the SD card. In the simulator it's important because by default the card isn't formatted. But so now you can actually save to a slot here, save, and then when you want to load, you can see project is saved on slot 1 here. So yeah, that's a project page. Then there's a layout page. So also you see if you hold the page key, you can use the left and right keys to move through the pages, or you can actually see on the LEDs here which page is active, and so you can also use the track buttons or the step buttons to access different pages directly. So this layout page is where you control or kind of set up the track mode. So there's node track, curve track, and the MIDI CV track. You can see that this change button appears as soon as you change it from where it's from its current value. That's because basically everything you do in the sequencer can be done while it's running. So there are a few things. For example, changing track mode. You don't want that to happen as soon as you change the value here. So you want to be able to select the one you actually want, because these are kind of destructive things, because the memory, so you lose all your patterns, for example, and you can't go back. So yeah, that's why there's a change button. And then there's a track link feature, which allows you to set the track to kind of follow another track. So if it's a sequence track and you set like some first and last step on a sequence, this allows another track to follow that playhead, which is really useful if you use a second track for adding modulation to a sequence. And then, yeah, whenever you change the first sequence in terms of the length, whatever, you also want that to be reflected on another track. One limitation here is that track 1 cannot have a link track. The reason for that is tracks are, at each tick of the sequencer, tracks are processed from the first to the last track. And to guarantee accurate timing, so whenever track 1 goes to the next step in the sequence, only the tracks coming later actually can know about this. So that's the reason why track 2 can only link to track 1, track 3 can link to 1 and 2, but nothing else, and then track 8 can basically link to any of the tracks from 1 to 7. And then there's one last thing here on the layout page, which is basically mapping sort of virtual gate and CV outputs of the tracks to the physical ones. So in general, if you're using just sequences or the node and curve sequence mode, track mode, then there's not a lot you want to do here, because the physical gate 1 corresponds to the track 1 gate, to physical gate 2 is linked to track 2 gate, etc. But things are a bit different if, for example, you use a MIDI CV track, because now this track can actually use, let's say I use 2 voices, and the voice config is I want to output pitch as well as velocity. So now you need 4 CV outputs for one track. And so you can do that by just change the layout here. So now you can see CV1, physical CV1 is mapped to track 1 volt per octave of voice 1, and then CV2 voice 2, etc. And then you can still have the other CVs being used for the other tracks. So this allows you to go crazy, use a MIDI CV to basically have 8 voices, for example. Or you can have 4 voices with velocity, or you can have 2 voices with velocity and aftertouch. Or you can have 8 different MIDI to CV converters listening to different MIDI channels and each outputting monophonic CV gate to the physical ports. So yeah, the idea is you don't really want to change this stuff that often. Basically, you set up a project, you set up your track modes, you set up this layout, you save it as a template, and then you kind of reuse this. The next page is the track page, where depending on the track mode, you kind of configure you configure the global track settings. So for the MIDI to CV track mode, this basically, you can set up a channel where you listen to. Also the MIDI port, is it the physical kind of MIDI in-out or a USB MIDI in-out? You can set up the number of voices, the voice configuration, pitch, velocity, or pitch, velocity, and pressure, pitch bend range, re-trigger, so basically the gate goes low every time you press a new key. There's one thing I want to implement in the future, which is the MPE protocol. So you could have this Rowley C-board, which allows you to kind of have individual pitch and modulation per key. This should be fairly straightforward, but I need to borrow the hardware to actually test it, implement it. So let's go back and actually use a note track again here. So looks good. So for the note track currently, also let's go back and actually use a curve track. So the settings on the track page are quite similar for the note track and the curve track. So you have a play mode, which this I haven't seen in any sequencers really. I mean, there are sequences that do it one way or the other, but basically the idea is if play mode is free or free running, it behaves a lot like an analog sequencer would. So decisions are basically, so you have a clock input and you have a division that kind of sets the speed of the sequence. Whenever your clock divided by the division hits 0, you advance by 1 step. And then everything follows from that. Like if you have a sequence that goes ping pong or goes just forward and loops back to the start point, you decide that on every kind of advancement of 1 step. So the problem with that sometimes can be that if you change certain things like the division or like first and last step, your sequence can end up being kind of off the grid, doing like weird things, which can be nice in some situations, but can be a bit annoying. For example, when you have like, you want to have more controlled sequences in a live performance. So I'm just reading. The simulator is interfering with your microphone. Actually, it's interfering with the fan of my computer, which is struggling with this whole setup here. So I hope you can still understand me. Yeah, as I said, I hope to improve the setup when I do the next stream. But for now, that's just unfortunate. Anyway, play mode. So yeah, the other mode is aligned, which is kind of deterministic. So whenever you change settings, basically the sequencer figures out where it would be if it was started with the settings that it currently has. So if you change first and last step of a sequence, then the playing step will change immediately to some other step, which it wouldn't for the free-running play mode. But you're always guaranteed to have kind of a deterministic result in terms of how the sequence is played. So if you decide to change certain parameters and then go back to the way it was before, you're guaranteed that the sequence will be at the exact position where it would have been if you never changed those parameters, basically. So it's just, yeah, it's a different way of thinking about how to evaluate kind of the current step instead of doing it kind of on the fly. It's basically an equation that is evaluated to determine the current step based on all these parameters every time the clock advances. Fill mode is currently a placeholder, but there is a fill feature which allows you to kind of trigger additional nodes or additional gates by just pressing a button, which is again kind of a performance feature. For now, fills will just basically activate every step in a sequence, but I have some ideas of different modes, so that's where this goes. Then there is transposition of the sequence, and then there's a rotate value here, which basically acts as if you would rotate all your steps in a sequence to the left or to the right. So yeah, basically you can either do that in a sequence directly by moving steps around, but having this parameter here allows you to do that very quickly and on the fly and as you perform, which is kind of nice to come up with different rhythms and yeah. So somebody is asking, could I talk a bit about how it compares to Eloquencer and BeatStep Pro? Yeah, I don't want to go into that right now. Let's first go over the features a bit, and then maybe I will talk a bit about other sequencers. I mean, I kind of borrow concepts from different sequencers, as you will find now that I go into the actual sequence. There is some stuff that is pretty close to what Eloquencer does, which is a lot more than, for example, BeatStep Pro does, and yet it's, for example, super different from what ER101 does. But for example, I'm using the voltage tables idea that is also used in ER101. So yeah, I kind of try to pick the concepts that I think are most usable, or kind of, and that's sometimes difficult because what is important for me might not be important for other people. Oh yes, and the Hermod. Yeah, there is some cool stuff in Hermod. Anyway, let's continue with the sequence page here, which is kind of the meat, I guess, in a sequencer. So as it is right now, you can see I have my steps here, and then there are different modes I can trigger here with the soft keys. If I'm in gate mode, my step keys will basically just change the gates. There's a cool feature, I think it's pretty cool. You can use shift, press shift, and then you can kind of hold down multiple steps. Let go, and now you have those steps selected. So even if you change mode, those steps keep being selected. And what you can do is, if you hold shift and you press one step and then double tap on another step, it will actually select all the steps in the given interval that is between the first step you clicked and the one that you double tap. And so this allows you to quickly select multiple steps. So for example here, it's like one step to not, one step to not. And this goes on through the whole sequence. And it can even go backwards. So I'm only selecting the first 5 steps. So yeah, that's gate. Then there's gate probability. So you see those bars below here, and then when you adjust it, it's just the probability value of actually playing that gate. Maybe I should actually start playing something here. Let's mute everything but the first track. So it's just a kick drum. Now if I load the probabilities, obviously. Then there's retrigger. Then again, this has there's a gate length. And I haven't really figured out how I want to do glides, and also at the moment the gate actually re-triggers for each step. So when you go to maximum length, it should probably keep the gate high for the next step, even so you can do longer gates. And then finally there is the note value, which for this track doesn't do anything because there's only a sample being triggered. But here it then depends on the scale. So there's a sequence setup page where you can set the scale. So there's a few scales that I've put in here. There will be more, and most importantly there will be user definable scales that I haven't implemented yet, but that will happen. And the nice thing about this is, it doesn't have to be chromatic. There are a few scales here that are chromatic, but then there's like 7 tet, 12, well 12 is just chromatic, but 24 tet, and then you can do your own stuff. I will still have to figure out what I want to put in here. And in addition to that, for the chromatic scales, I also need to allow people to define the root note, which is not implemented yet. But so what's kind of neat is, depending on the scale, the stuff that you see on the sequencer itself, it actually it doesn't use notes like C, D, E, F, G, but it actually uses numbers 1, 2, 3, 4. But then it still uses B for flat, and then there should be sharp somewhere. I don't know. So if it knows it's a chromatic sequence, you can still kind of get those note names being displayed. Then on the bottom row here, you can see the octave. Now, one thing that I wasn't really sure about, and I'm still kind of struggling, is the fact that depending on what scale you use, you may have just 5 notes in a scale, or 7, or 12, or whatever. And then if you change that scale, your sequence might end up using a pretty different range of pitches, because yeah, if you use a 12 semitone scale and then go to like a pentatonic scale, your octave will be every 5 notes and not every 12 notes. But yeah, I think that's kind of there's not a good way to solve this, basically. So I don't think that changing scales as the sequencer is running is the best idea. The next thing is the division. So you have like all the standard 16th, 8th, 4th, up to full note, down to 64th note. And then you also have triplets. And if you hold shift, you can actually use divisors between those values as well, to give you some really off the grid stuff. And to help with this, you can set this reset measure value. So if this is off, the sequence will just run. But if it's on, you can basically reset the sequence every 8 bars, for example. So this allows to kind of have a bit of craziness, but then every once in a while you go back to kind of, yeah, you reset the sequence. Then there's run mode. That's pretty standard stuff: forward, backward, pendulum, ping pong, random. And then you can define first and last step for the sequence. And yeah, that's about it. So these parameters here, they are per sequence. So basically in a track you have 16 sequences, and every sequence kind of has this this set of parameters that you can use. Now if we go, yeah, let's crash the sequencer. Great. Just quickly want to show you how the curve sequence looks like. So basically my idea here was, it's a thing that is available in Native Instruments Massive synth VST plugin. And so now every step basically is a curve. I will still work on these, but so you can make these sort of funny modulations. Yeah, you can set the shape, and for now then you can also kind of set the minimum value and maximum value of each step here. Doesn't do anything right now, but I mean, yeah, because the simulator doesn't react to this CD. Also, yeah, I still have to figure out what I really want to do with this, but I think it's going to be a nice feature to do modulation that's a bit more elaborate than just having LFOs, which a lot of sequencers do. Maybe I will also add an LFO mode, because that's probably simpler. But you can basically, by just using one step and then playing with the division, you can basically emulate LFOs as well. But you can do a lot more. So here, instead of the scale, now you have just a range of the voltage range that is actually output. The rest is basically the same as with node sequences. What do I want to cover next? Let's look at the project again. Pattern page. So basically here you select with left and right keys. I mean, the UI is not great right now, but basically you can select the sequence that you're editing, and then with the first row of step keys, you select. No, sorry. With all the step keys, you select the patterns 1 to 16. You can also hold the edit key here and then use the step keys to select the edit pattern instead of using like the left and right arrows. And then here is the first place where I use this sync measure. So if you can instantly switch patterns, or you can hold shift, and then depending on how the sync measure is set up, it will basically schedule a pattern switch, but it will only execute it on the next sync point. And then what's more is you can hold down track keys and basically only switch a pattern on one track. So yeah. This, yeah, I realized when I was actually playing with the sequencer a bit, this pattern switching, how you select the pattern to edit, that's not really, yeah, the workflow is not great yet, so I will have to work on that a bit more. There's also, again, with this kind of page shift combination, you can access additional functionality, so you can init just one pattern, the current edit pattern, to the default, which is just an empty sequence or an empty pattern. You can copy paste, so I can go pattern 1, copy, go pattern 2, paste. Now I have the pattern on both. Yeah, copied the pattern 1 to pattern 2. There's also this duplicate feature, which basically takes the current pattern, copies it to the next, and immediately switches to the next pattern. So that's kind of yeah, a good way to, if you have something going, then you just hit duplicate and now you have a new copy and you can do some changes, go back to the old pattern. The next page is this performer page, which basically yeah, it mostly does muting, basically. So you can mute tracks, and again you have this synced mute, so if you hold shift and mute the track, it will only mute it on the next sync point. You can also disengage, so if you have, yeah, And this is great to do multiple mutes at the same time. There is one feature I would like to implement is kind of you hold a button and you select the mutes and unmutes you want to do, and as soon as you release the button that you pressed first, it actually does the changes. So yeah, I want to maybe figure out the way how to implement that. So top buttons here are basically mute everything, unmute everything. And then the bottom row of the step keys is basically solo, so it mutes all the tracks except one. And again, this works with Shift to do it in a synchronized way. And then finally there is fills. So by pressing the track keys, you can enable fill, or by holding the global fill key here, you fill every track. So that basically does, as I said before, right now, just fills every note. But yeah, I want to add different modes there. Even things like fill could be just temporarily switch to the next pattern, so you can always use two patterns, two adjacent patterns, and switch to the fill pattern by pressing this key. So yeah, that's basically the idea of fills. So yeah, that covers kind of the main functionality, I would say. This is also something that I haven't really figured out yet completely UI wise, is how to access certain, like the sequence parameters, which you probably want to access quite. You want to be able to change these quickly. So my current idea was you have these by holding page, you can switch through pages, and then for now this the first row of pages is kind of the global, like most important stuff, and then the second row basically jumps to directly to sequence parameters. And then by just pressing the track key, you can access the parameter of different tracks quite easily. But yeah, I'm not completely sold on that yet. Anyway, let's continue. I guess one thing that people probably wanna see is, for example, let's go to this. Let's only play this note sequence here. So in the track page, I can have this transpose, and then rotate, and now what I can do is go to this context menu again. There's also copy and paste for tracks, so you can take one track and all its sequences and just copy it to another track, or you can initialize the whole track with an empty track. But then there's this route key, and that only shows up for the parameters you can actually, or is highlighted only for the parameters you can actually route. And so if I press this for transpose, for example, it automatically creates this first route for me. I see the parameter here. I can set a min and max value. I can select which tracks this route is affecting. So basically, because I was on track 8, it only selected this first this track, but I can also enable other tracks, and then I can select the source. So for example, let's use CV1, and then because this again is kind of a destructive feature, you have to kind of manually say, well, change this, like make it active. And now you can see this on the hardware, this is CV input 1, and this now controls the transpose. I can go back to this routing page, and I can see for now I have 16 routes, but I will probably add more because they don't need that much memory actually. And then the other thing you can do is basically hit this learn button, which is using MIDI learn. So now I was just turning one, or moving one slider on my MIDI controller, and you can see it automatically assigns the port. If this was over USB MIDI, it would use USB, the CC number, and it also figures out if this is actually a relative or absolute source. And if I hit change, go back now, I can use the slider to set this value. And for MIDI MIDI sources, there's actually quite a few things you can do. You have control change, CC, absolute relative, but you can also use the pitch bend. You can use individual notes. So again, if I hit learn and I just press some notes, or kind of re-trigger the same note on the keyboard a few times, it will assign this. And now note momentary just means whenever I hit this button or this key on the keyboard, it will change the parameter as long as I hold it. There is note toggle, which basically whenever I hit it, it will switch between the two values on and off. There's also note velocity, which you can use to, depending on how hard you press, it will set the value. So yeah, when I was playing around with this a bit, it's actually pretty cool what you can do with just a few of those routes to some parameters. Now there's a lot more I want to add. For example, in note sequences, you have these probability values, or just the gate length, stuff like that. So what I want to do, or will do, is on the track page you will have kind of offset values to those. So for example, gate probability, by default it will be 0, but you can go positive or negative to kind of adjust the value that's coming from the sequence, and then you can actually make a route to this probability value on the track, and then you can use a controller to actually control globally on one track or on multiple tracks if you enable the route for other tracks as well. You can basically, yeah, use one controller to control these things hands-on. And again, this is something that you probably set up once in a project. Yeah, I mean, you decide what track is going to do what in your modular, be it the baseline or a lead or just triggers, and then yeah, set up these controller mappings. So yeah, that's routing. Yeah, there's a simple monitor page here, which basically just shows the raw voltage value that's on the inputs as well as on the outputs. So because we only have one sequence, yeah, you can see. I was talking a bit about generators, so this is kind of the template for Euclidean rhythms. So the idea for this is, I still don't really know how to do it nicely, but basically I want, if you're on sequence, I want to be able to kind of use these functions or these generators to swiftly enter data into the sequence. So this Euclidean rhythm thing would obviously only set up gates, but it could also basically adjust the other parameters, probability. And so my idea is, if you enter one of those generators and you can play with it, actually do it while the sequence is running, so you can feel that it's effective, and then if you want to accept the changes, or you can discard the generator. So it's not like, I don't plan to make these things, at least, I don't see a good way of doing it. Make these MIDI mappable and like have those persistently being active, but they are really tools to kind of shape a sequence quickly. But I have some ideas for, because in a lot of sequencers what you get is kind of these random, you can randomize stuff. I mean, I definitely want to do that as well, but I also want to do other things. Like, I mean, there's, for example, Turing Machine, which uses this simple shift register idea, and you could apply the same concept here. So it's still sort of random, but it's not like random on every step, but it's it has more structure. I also read about quite a few techniques to be able to generate melodies. So that was actually really a thing when I started this project. I really wanted to get into this. And this is probably also the link to Hermod, because Hermod is, with its concept of those effects that you can chain together, it's going into that direction where you start out with something really simple, and then through applying these effects, you get to more complex sequences. But yeah, I still want to have this more traditional sequencing engine, and I'd rather, because the thing is with these like generative algorithms for creating patterns, it can be cool to just experiment, but a lot of times it takes a while to actually find something that's useful or kind of hits the spot. And so my idea was more that you can drive this process a bit more in a bit more controlled way, where you can try stuff but immediately go back if it's not what you want, and only keep the stuff that you actually like. and then by having a snapshot system that I haven't really implemented yet, but the idea there is to be able to store changes to sequences, or kind of create a copy of a sequence and then do changes on that, and then still be able to go back to kind of the original sequence that you started with. So, I mean, basically, I want to have a set of tools that allow me uh, to let the sequencer do stuff for me, but only kind of keep the things that I actually want, and then still be able to edit the result. Like, that's the other thing. If you have these purely generative things, it's the output is what you have. But if you think one part of it is super cool, then it's hard to kind of extract that part and do something with it. So yeah, that's something that I would like to be able to do. Like, by baking these things, or by uh, using those generators to adjust or change the sequence itself, you can always then edit individual steps later on. So yeah, that's, I guess, about it for now. Um, yeah, so there's this comment by Vladimir about the scales. I mean, a lot of sequencers, they have a basically chromatic scale, and then if you quantize, you just move nodes to the nearest node in the scale. Um, yeah, I didn't really. I actually like this voltage table idea a lot for different reasons. First of all, is you can have an arbitrary scale, which is neat, especially if you think about it. If you think about controlling CV inputs of modules that actually use CV ins to change a mode. For example, like a chord module. Um, if you can do a voltage table, you can index the different kind of inputs of another module in a more controlled way. So you can set up a table that, for example, really indexes into the different chords of a chord module. Um, with a traditional sequencer, that's just not possible. Or it's super finicky. You need maybe some attenuation on your output, uh, and so yeah, that was kind of the main idea, or some of the reasons why I wanted to use those voltage tables. You mean you store voltages internally? Um, okay, yeah, that would be an idea, but uh, with the current memory limits I have, it's not really possible, because you would have to store 16 bits, or like at least 14 bits. Right now I'm only storing 8, so that's almost doubling the size of a sequence. No, not really, because you have other parameters, but it's a considerable amount of additional data per step. Yeah, it would be neat if you could actually store the voltage instead of an index. Um, yeah. So I'm not sure if there are any questions regarding kind of the difference to other sequencers. I mean, yeah, it's every sequencer has a slightly different feature set, I guess. My main goals were to have something that's really kind of suited for live performance, I guess. I'm not sure if if I'm actually there, because the few sessions I did, yeah, it's just I don't have enough muscle memory with it yet, and a lot of the features are still missing. So I can only judge the things that I already have implemented. But I think there are a few features like the synchronized change of patterns and mutes and stuff like that, which I really like. I mean, you can always, other people will just add a bunch of on-off switches on the gate outputs, which is also nice. But to have kind of some higher level functionality on these things is for me pretty important. I always hated devices that did have simple stuff like mutes, and then it's not accessible easily. That's for me just a no-go. Sam, thanks, Vladimir. 200. Yeah, it's 8 bits. Maybe it's too much. I mean, that's a great thing. Maybe I can reduce memory in a few places. So yeah, maybe I want to talk just a little bit about some ideas I have that I still want to work on. So there are a few obvious things, like there is always a lot of cleanup. The UI is not perfect. There are inconsistencies, but overall I'm kind of happy even with this. I thought about, for example, right now there's a lot of kind of these list pages where you have kind of this typical menu thing. I thought about breaking that up completely and do something similar to the Electron devices, for example, where you have all the parameters on one page, and you kind of I would then kind of switch through those parameters with the soft keys F1 to F5. But that's just a lot of work, and in some places it would turn out quite nicely. In other places, I think it's not the best way to do things. So I think for now I stick with this kind of menu system. Because it's easier to change stuff, and I can always. I mean, once I have like a good idea of the feature set, I can go back to this and maybe rework some of the UI. But there are a few things left to do. For example, the voltage table scales, also the root node, and I was thinking about ways to actually allow changing the scale as a sequence runs. So one idea I had sort of that you could set up a list of scales and root nodes on the project. So basically have like define like a progression in terms of defining a few scales and root nodes. And then being able to address these scales in the sequence. But I think, yeah, for like the first release, I'm not going into that. I don't really know of any sequencer that has a feature like that, so maybe it's not something that a lot of people actually want. And it, yeah, I think it can be quite confusing also. What I definitely want to add is those additional parameters on the track for changing gate length, the probability, stuff like that, because I think that's a really cool performance feature. And I also have to figure out how to do node ties, like longer gates. I want to add glide. That would also be a track parameter. Yeah, that a lot of these things are pretty small, easy to implement. I definitely want to do more work on the curve sequencer, but it will probably be pretty basic in the first release. Yes, and then this generator thing, yeah, I will see if that's something. I mean, yeah, I have a lot of ideas. I'm just not. I don't have a good plan. So yeah, it basically will be a lot of trial and error, I think. So I'm not sure if it's going to be part of like a first release. So yeah, I think that should give an overview of where I'm at. If you have, there are four listeners or viewers, which is great. If you have any other questions, please just go ahead. Otherwise, I will probably close this pretty soon. And then, yeah, the next stream, I will hopefully be able to show the actual hardware in action, like have the Eurorack connected to it. Yeah, because it's actually nicer, a lot nicer on the hardware than on the simulator. I also didn't really show a lot of, yeah, kind of what I would like to do in a stream is also kind of do a quick jam session and just show some of the stuff you can do with it. Yeah, because that's really, I guess, what's all about. So this was more about just showing one feature after the other. I hope I covered most of it. Maybe there's some stuff I didn't, but yeah. So, all right, if there's no other questions, feel free to, I mean, the stream will be on YouTube, so post questions to the comment section. I'll definitely try to answer them. And thanks for hanging out. And then I will see you maybe in a few weeks, hopefully. Okay, thanks a lot, and bye-bye.